Get something to write with. Do this. Here we go. All right, so guys, for the last 2 class periods, you have been learning how to write the names and formulas for salts. Guys, today, same game, different players. Today, you're going to be writing names and formulas as well. But not surprisingly, given what you learned a couple of units ago, salts are not the end of the story. We understand that salts are compounds, but they're not the only compound. There are also molecules. So we'll talk about the differences, you probably remember. But guys, you need to learn to name and write the formulas for molecules. And the thing is, the rules are completely different. You don't use Roman numerals, you don't use parentheses, you don't work it backwards, you don't do any of that stuff. So guys, there are rules, they're just different rules. So I'm going to teach you the rules. We're going to do 5 examples and then summarize and call it a day. You ready? So guys, it goes like this. So just teeing up the ball, you don't need to write it down. Guys, for the past couple days, as I said, we've been playing around with salts. Simple salts, the complex salts. We've talked Roman numerals, we've talked balancing charges, we've talked about parentheses, we've talked polyatomics. All of these are ionically bonded salts. Well guys, today what we're going to do is we're going to do the same work with covalently bonded substances that are called molecules. So guys, remind yourselves, what atom combination creates molecules? Is it metal to metal, metal to nonmetal, metal to metal, or nonmetal to nonmetal? Non-metal to non-metal. Remember the idea, like the kids in the nursery, right? 2 strong, horrible kids latch onto a toy. Neither one lets go because they're both strong, and you get 2 for the price of 1 because they're locked together, right? Well, guys, the same thing's going on here. When 2 nonmetals get together, they're locked together, they form molecules. So, guys, remember, though, the tricky guy was hydrogen, right? On a previous test, you had to identify if something was a salt or a molecule, and we learned that hydrogens actually form molecules even though they're metals. What was the idea? Yeah, they're freakishly strong. Is hydrogen a metal? Absolutely. But it's such a strong metal that nobody can steal from it, and therefore it forms molecules as well. Is it all coming back to you? Okay, so guys, this is where you want to start taking notes. So now that you understand what molecules are, or maybe you're remembering what molecules are, the question we need to answer now is, how do we name them? How do we write the formulas? Guys, you're almost done taking notes, and we haven't even got, this is your only page of notes. It's down to there and you're done. So guys, these are the rules for working with molecules. Rule number 1 is this. You don't use Roman numerals. When you're naming molecules, you use prefixes. And guys, this is not unfamiliar to you. You've all heard of carbon dioxide, right? How many oxygens? How'd you know? Di, it's a prefix, right? Guys, this isn't really that crazy hard. So the idea is, with molecules, we indicate how many of each atom, carbon dioxide, by using prefixes. So the tricky bit is knowing the prefixes. So if you'd like to write these down, I think you would benefit from that. Although my suspicion is you're going to get into the middle of writing these down and you're going to go, wait, that was pretty obvious. But I'll give you a second to write them down if you'd like, and then we'll talk about them. And then there's just a couple little itty-bitty rules that we need to go over, and then, guys, we are almost done. You realize the beauty of this is you're going to get your homework done tonight, and you won't have homework over the weekend. It's going to be lovely. Y'all done? You guys good? Okay, so guys, let's talk through these, because I would propose to you that there's only really 1 or maybe 2 of these that you've got to memorize, because the rest of them you knew. Guys, mono. You knew that was one, right? Monorail, one rail. We've all been to Disneyland because that's a rule in Utah. Guys, mono, right? Okay. So you knew that carbon dioxide was 2. That's di. You know a triangle has 3 sides. That's tri. You learned in a previous unit that tetra means 4 because tetrahedral means 4 domains. Guys, penta could be a stretch unless you realize that people that work in the Pentagon live in a building that has 5 sides. You might know 5 is penta. So, hex is 6. I don't know, does anyone have context for that? Well, sure, hexadeca, but that's just knowing the definition. Not like tri, where you picture a triangle. But guys, if you knew that hexa is 6, now you know. 7 is a stretch. That's actually hepta. That one may be completely new to you. Octa had better not be unfamiliar because you learned the octet rule. All right. So guys, nona is 9. For me, that makes sense because 9 and non kind of sound the same. And then guys, you know there's 10 years in a decade and you're done, right? So there isn't that much to memorize. Maybe hepta is 7. You might have known hexa is 6, and then nona sounds like 9, and you're done. So, guys, what do we do with these things? Well, here's the only tricky bit. When you are naming compounds, molecules, if there is only one of the first atom, you do not use mono. But guys, you actually already knew that. Again, if there's only one of the first atom, you do not use mono. But again, I would propose to you, you knew that. What gives me the suspicion that you knew that? Because guys, you know that this is what? Carbon dioxide. Why don't we call it monocarbon dioxide? Well, guys, the reason is because of this rule. We don't call this monocarbon because if there's only one of the first atom, you don't include the mono. That's the only prefix you don't use, is if there's one of the first atom, you don't use it. So, guys, with that in mind, this also exists. 1 carbon, 1 oxygen. It's a horrible, deadly gas. What's this called? Carbon monoxide. Notice there we do use the mono for the second atom because it's not first. So it's not monocarbon monoxide, it's carbon monoxide or monooxide. You could do either one. But guys, we do use mono on the second one. That's the only tricky bit to all of this. Yeah, so, and then guys, everything else is familiar. So we add IDE to the end of the second element. It's not carbon dioxygen, it's carbon dioxide, but you learn that with the salts because we always end IDE to the ends of the names of the second element. Not too bad, right? So guys, we're going to do 5 of these. I'm going to give you 3 formulas. We'll write the names. I'm going to give you 2 names. We'll write the formulas. Then we're going to summarize and call it a day. Here we go. Can I go? Is that okay? All right. So guys, let's try these. SF6. I wonder, well, let's try this. We'll write the first one down. Yeah, so guys, all you got to do if you know that S is sulfur, and if you know that F is fluorine, you're done. So let's name this thing. How many sulfurs are there? 1. Do we call it monosulfur? No, because we just learned we don't do that. So we write down the word sulfur. Now, new word, this isn't one word, new word, we've got fluorine. So what are we going to change fluorine to? Fluoride. How many of them are there? There's 6. The prefix for 6 is, so it's hexafluoride. Guys, that's all there is to this. The only thing that gets weird about these is if you've got a prefix that ends in a vowel and you've got an element that ends in a vowel, what do? And the answer is, we'll let you do whatever you want. So for example, if you've got this. You don't need to write it down. But if you've got carbon monoxide, we've got mono, and we've got oxide. So when we bring those together, what do? Well, you've got choices. You could drop one of the O's. That's typically what we do, and we call it monoxide. But you could also leave both O's and call it monooxide, and you're okay, because that's the only thing that makes naming these things weird. So let's take a stab at this. So next example, N2O. Take a swing at it. So guys, let's do this. We know that nitrogen, we know that N is nitrogen, we know that O is oxygen. The question is, how do we deal with the prefixes? So there's 2 nitrogens. Do we add di for 2? Yes, because it's not 1. Guys, you always add prefixes except for one of the first one. So this would be di nitrogen. Now guys, we've got 1 oxygen, right? So, do we put the prefix mono? Absolutely, because it's not first. So, you could call it monooxide, or you could just call it monoxide, and that works. Now, guys, there's one more example that I want to show you just to bring this out. For some of you, this molecule may be familiar. If any of you are into tuning cars, you've probably heard of nitrous oxide kits. That's this. But there's another name for it. But you squirt this stuff into the engine of a car, and it makes it go faster. The thing that's really crazy is nitrogen and oxygen, when they get together, there's actually 5 different ways they can bond. This is 2 of them. But there's actually 5 different nitrogen-oxygen molecules. They all exist. Okay, so guys, let's take a shot at this. Are we going to call this mononitrogen? No, because it's first and we don't add it. But, so we've got nitrogen, and then we... I guess I can write it out for you. So we've got nitrogen, and then guys, we've got 2 oxygens. So in this case, we're going to keep both vowels because it would be silly to call it didoxide. So it's dioxide. So nitrogen dioxide looks like so. You good? All right, so guys, let me just bring in the rest of the examples. It goes like this. So what if we go the other direction? Dichlorine octoxide. Now we need to write the formula. Guys, it's really this simple. Chlorine, oxygen, how many of each do we have? Dichlorine is 2, oct is 8, you're done. Told you this goes fast. So guys, and then the final example, I just thought I'd use it as an opportunity to show you the third of the 5 nitrogen-oxygen compounds. We've got nitrogen, we've got oxygen, di is 2, tetra is 4, we're done. That's it. We're done. So guys, you have now maybe learned, but certainly been exposed to all the material in this unit. There's nothing new that's going to come at you for the rest of this unit. What we're going to do is we're going to spend today solidifying. Hold on though. We're going to spend today solidifying. Wednesday we're going to explore this in lab. Or wait, Wednesday? Friday, Tuesday. Tuesday we're going to explore this in lab. Thursday we're going to reinforce, and Monday's the test. So guys, with that said, here's the thing that's going to make this hard. Let me just show you. So, you now understand the rules for naming molecules and writing the formulas for molecules. Here's the problem. Some of you are going to think that this is nasty and evil, and that's okay. But guys, this is kind of the way the chemistry world works. Here's the problem. Let's do let's do this. Let's name it. Actually, no. Let's do this. This will be even better. Let's name it. So, dicopper monosodium tetroxide. No, it's a salt. And guys, the rules for salts have nothing to do with what you just learned. You learned the rules for molecules. And so guys, you now have two different skill sets in your mental toolbox. You've got the rules for naming and writing the formulas for salts. That's the last two homework assignments. Now you've got the rules with the prefixes for naming and writing the formulas for molecules. And these are pretty straightforward when they're separate. But guys, the world isn't separate. You're going to walk into lab on Tuesday and you're going to be handed bottles. Some of them are going to contain salts in solution. Some of them are going to contain molecules. And you've got to be able to tell the difference and then apply the proper rules to name and write their formulas. Because guys, and some of you are going to do this on the test. I'll just tell you right now from experience. You're going to see this and your brain is going to go, prefixes are easier. That's what I'm going to do. I'm going to call this dicopper monosulfur tetroxide. No, this is copper 1 sulfate. And if you don't understand why it's copper 1 sulfate, you're still in trouble. Because what's the first thing we do? Well, we look at, once we identify that it's a salt, we look at copper and we go, oh my gosh, copper can have more than one charge. And if copper has more than one charge, I need to break it in half. And then I need to look up the charge of sulfate. And sulfate's -2, but it's not -2 times 8 because the whole sulfate has a -2 charge. So it's -2 times 1 is -2, and this is +2. And +2 divided by 2 is 1. So this is copper 1 sulfate. See guys, this is where this gets weird. On their own, they might be a little weird. You put them together, and there's the possibility that it gets really weird. Guys, this is where this kicks in. This is a summary of everything that you've learned in the last 3 days. But guys, this is actually organized as like a diagnostic tool. This is stepping you through how to name and write the formulas for salts and molecules. And honestly, Mrs. Clay and Mrs. Clay and Miss Call and I built this yesterday after school. We were like, we know that our students are going to struggle with this. And frankly, I've just been putting this off for years. I'm just a neglectful teacher. This is something we should have done a decade ago because kids struggle with this every year. And finally, we sat down and said, let's put it in print. So guys, this is how this goes. You are confronted with a substance, CuSO4. What is the first thing that you've got to do? Well, you got to figure out if this is a salt or a molecule. But guys, check this out. The logic makes wonderful sense. What atom pairings make a salt? Metal and non-metal. What makes a molecule? 2 non-metals. So guys, when you write the chemical formula or the name, this is going to be the difference. If it contains a metal, which always goes first, right? If it contains a metal, it's going to be a salt. If it contains 2 nonmetals, then it's going to be a molecule. So all you have to do is look at the first element. If it's a metal, it's a salt. If it's a nonmetal, it's a molecule. So that's what this is talking about. The first thing that you're going to do is you are going to look at the first atom in the compound. And then guys, this becomes a problem-solving thing. If that first atom is a metal, it's a salt. If that first atom is a non-metal, it's a molecule. What that has done is it is now identified for you the rule sets to use. If it's a salt, now you're thinking about the homework we just graded. Writing formulas and naming salts. It's polyatomics, it's parentheses, it's all of that. Guys, if it's a molecule, it's everything that you just learned about prefixes. So then what I did is I tried to put this in a nutshell for you. So guys, let's talk naming first. So how do we name salts? Well, guys, here's Cu2SO4. What is the first thing we did to write this form or write the name? Look it up on the periodic table and see if it's got more than one charge. Oh my gosh, copper can have more than one charge. Because it can have more than one charge, what do we have to do? Break it in half and work it backwards. Figure out what the charge is and represent it with what? A Roman numeral. Guys, that is what all of this is about. First step, check on the periodic table if the metal has more than one charge. If it does, work it backwards and use a Roman numeral. If it does not, just name the thing. Remember, for reference, that the second element, which will be the non-metal, will always, if it's an element, it'll end in "ide." If it's a polyatomic, it's an "ate" or an "ite," with the exception of cyanide, hydroxide, and peroxide, which are polyatomics that are on the periodic or on the ion chart. Yeah. 8 is more oxygens and ite is less. So sulfate is 4 oxygens, sulfite is 3, nitrate is 3 oxygens, nitrite is 2. So it doesn't give you a number, it just says more or less. Okay. Now guys, what if you look at that first atom and that first atom is a non-metal? Well, now you know it's a molecule. So guys, if it's a molecule like CO2, carbon is a molecule, carbon is a non-metal, so it's a molecule. How do we name this thing? Well, we need prefixes, right? 1 carbon, 2 oxygens, carbon dioxide. But remember the little tricks. We're going to use prefixes to indicate the number of atoms. Again, if there's only one of the first atom, don't use mono, and the second element adds an IDE. This is becoming valuable, right? You can thank Miss Call because frankly my response was, our kids have done fine without it. Let's just blow it off for another year. I know I'm a horrible person, right? So guys, what about writing formulas? You look at the name and now you've got to write the formula. It says manganese 4 chromate and you got to name the thing or write the formula for the thing. Well guys, here's what we do. Just like the homework you graded. Write down the abbreviations and the charges for the ions. Again, remember polyatomics for the most part end in "ate" and "ite." Then find the least common multiple. That tells you where the positives and negatives match up. Then use that least common multiple to figure out how many of each atom or polyatomic you need. Remember then, guys, if you need more than one polyatomic, it goes in parentheses. And that is the only place you'd use parentheses. Atoms never go in parentheses. And if you only need one polyatomic, it also doesn't go in parentheses. Have a what? Oh, no, because that would necessarily then be a salt because it would be ionic because those things always function as ions. Yeah, good question. So, coming back to you. So guys, what if you've got something that is a molecule, a non-metal first, and you need to write its formula? Well guys, that was the silly stuff that we did at the bottom of the previous page. Read the prefixes, that tells you how many atoms, write the formula using subscripts. Okay, so guys, obviously this is not something you'll be able to use on the test, but it's definitely, I think, a great thing to reference. So now guys, grab your homework and let's talk. Goes like this. Assignment number 3. So at the top, and actually that title should be a little different. So in the first 10, you're naming molecules. In the next 10, you're writing formulas for molecules. They're all molecules. Next page. Uh-oh. Now they're mixed. It tells you at the top, mixed. So guys, this is where that chart might become handy to you. You're naming these things. But if it's a salt, you're going to name it with a completely different set of skills than if it's a molecule. So again, how do you know? Look at number 1. What's the first atom? Sodium. So is that a salt or a molecule? Sodium's element number 11. Sodium's a metal. It's a salt. Now you're thinking Roman numerals, polyatomics, all of that stuff. Work it backwards if you need to. Look at number 2. Phosphorus. Phosphorus is element number 15. It's on the right. It's a nonmetal. It's a molecule. Go from there. Then guys, similarly down below 11 through 20, now you're writing the formulas. They're still mixed. Then flipping it over again, they're still mixed. So guys, the first page, it's just molecules. The next 2 pages, they're blended, and you're going to have to differentiate. So guys, the remainder of the time is yours. I am going to print for you the answers, and I'll put them on the wall. You're welcome to access them on your phones. Let's get this done, guys. Focus. Let's get to work. Laura Lee, I still want